Question 16. A maintenance planner looks back on time taken to repair a centrifugal pump. Probably not relevant. The past data indicates that the repair time in hours T is distributed as T equals x, where x is a normal distribution. There is a shutdown coming up, and operations supervisor wants to know the probability that a repair will take more than 4 hours. Which is of the following is the correct value for this probability? Okay, so you first need to pick what kind of distribution this is, and it's a bit similar to one of the quizzes, so hopefully this sticks out as being log normal. So in here we've got two things that should tell you it's log normal. One is that x is a normal distribution with an average of 1 or mean of 1 and variance of 4, and that T, which is the distribution of the thing that we're looking for here, that's the number of hours, is x of T of x, which means that log T or ln T is equal to x. If you take natural logs of both sides, we get ln T is equal to x. So that means that ln T is log normal because x is x is normal, so ln T is normal, and that's why it's called a log normal distribution. So what does that mean? Well, we know that x is a normal distribution, and we know that ln T is equal to x. So we want to try and put something as easy as possible into our tables, and if you remember the calculation to work out just a normal z, it's pretty straightforward. All we need is the distance between the value given and the mean divided by the square root of the variance, or the standard deviation. So if we've got a normal distribution, we're trying to find a z statistic, and it's equal to whatever our value is, which in this case is going to be, we'll come to that in a second, whatever the value is, I can't remember how to denote it, so I'm going to give little x, minus 1, which is the mean, divided by square root of 4, which is 2. So what is this little x that we're going to do? Well, that is going to be log T. So in this case we're given that T is going to be equal to 4 hours. So we need log 4. Let's find out what that is. It's like 1.3863 minus 1 all over 2, and that's going to be our z statistic. So take 1 equals divided by 2 equals 0.193. Well, 0.19 will probably do. So if I just flick over to the Z tables, which if you have a look at table 3 in the stats book, which is Appendix B, page 515 on mine, it's also given in the it's about the third last page of the formula sheet you're given this year, and we want to find 0.19 in there. So go down to z equals 0.1, go all the way across to the 0.09 column to give z equals 0.19, and we're going to have the probability, I'm going to draw a little box here, the probability of z being less than 0.19 is equal to 0.5753. So is that the answer that we want? That's certainly in there. 0.58. So it's there to trick us. But no, that is the cumulative probability of z equals negative infinity all the way up to z equals 0.19. So, and we actually want the probability that a repair will take more than that. So we want 1 minus that. So the probability that Z is greater than 0.19 is going to be equal to 1 minus 0.58 in 2 decimal places, and that's going to give us 0.42. So with these log normal ones, they look tricky, they're not tricky. All you have to do is, instead of plugging in the value that you're given straight away, in this case 4 hours, you take the ln of that value first, or the natural log of that value first, and then you've got a normal distribution that you can apply your Z table to.